Hello, today we're going to start solving exponential equations. So exponential equations, just like exponential functions, have the x or n or whatever variable is up in the exponent. That's why they're called exponential. We are able to solve equations like this, even though they're not things we've seen before, by using mostly methods we've done to solve other types of equations. The big key concept that's new for these is that if you have the same base on both sides, I'm going to call that base b for now, what you're able to do is cancel that base on both sides and then make an equation out of the exponents, set them equal to each other. What we're going to see today is a little more complicated than that, but the concept is the same. If we have the same base on both sides, we can cancel those bases, set the exponents equal to each other. So let's try some out actually using that concept. So notice here in this first one, my base, the big number on both sides, is 5. Since it's the same base on both sides of the equation, one of my properties says I can cancel those bases and set the exponents equal to each other. So 5 to the x plus 1 equals 5 squared. You cancel those 5's, it turns into x plus 1 equals 2. From here, that's a type of equation you've been solving for a very long time. We just need to get x by itself, and so we end up with x equals 1. So this beginning equation looked a lot more complicated, as since the bases were the same, we could cancel those, set the exponents equal to each other, and solve. Let's try another one. So again, my base is the same on both sides. My base is 6. I can cancel that 6 base on both sides and set the two exponents to each other. So this side is 2r, other side is 2 minus 2r. Goal here is to get r by itself. We need to get our r's on the same side of the equal sign. I'm going to do that by adding 2r to both sides. 2r plus 2r is 4r. And then the last step to get r by itself and solve this one is to divide by the number in front of r, which is 4. 2 over 4 reduces to 1/2, or if you like decimals better, it's 0.5. I don't care if you write your answers as a fraction or decimal, either one is fine with me as long as it's the correct number. Now these last two that we're going to look at for today are slightly more complicated. We just need to think about our exponent rules. So this is a more complicated version of our product rule. When I have two things with the same base, I add the exponents. I'm going to do the same thing here. So 6 to the 1 minus 2x times 6 to the 6, or 3 minus 3x, I can turn that into my base 6, and then add these two exponents together. 1 minus 2x plus 3 minus 3x. On the other side, I only have the one base with exponents. There's nothing I can simplify there. We can kind of do a couple things in the next step here. I have the same base on both sides, and that base is only written once on each side. So now I can go ahead and cancel those bases. Also, I can start combining some like terms over here. Negative 2x minus 3x is negative 5x. 1 plus 3 is 4. Other side, there's nothing to combine yet. So now I solve what's left in red. It's an equation like we've done many times before. I start by getting my x's on the same side. I'm going to choose to do that by adding 5x. You could have added 3x, that would work too. And I get 2x. And then I'm going to get my numbers on the same side by subtracting 3 from both sides. 4 minus 3 is 1. And then to finish this off, I'm going to divide both sides by the number in front of x. And I get x equals 1/2. So, again, we simplified this by using our product rule. Once the bases were the same on both sides, we canceled them, used normal things we do like combining same side like terms to solve equations, and then got the variable by itself, just like solving any other equation. The last one for today is a similar concept, except for we have division. So we are going to use our quotient rule. Remember that if I have same base on top and bottom of a fraction, I simplify that by doing top exponent minus bottom exponent. So x to the a divided by x to the b becomes x to the a minus b. Same concept here. Instead of writing this fraction, I can rewrite that as 3, and then top exponent minus bottom exponent. So negative p minus the bottom exponent 3p. Other side stays the same for now. Hey look, I have the same base on both sides. So now my next step is to drop my pen apparently. Cancel that base on both sides. I can also combine like terms here. Negative p minus 3p is negative 4p. And then solve the equation. I'm going to do that by adding 3p to both sides. I get negative 1p or negative p, however you want to look at that there. And then divide both sides by the number in front of p, which is a hidden negative 1. So my final answer here is p equals positive 2. So when we're solving exponential equations, if we have the same base on both sides, we can cancel those bases. We may sometimes need to use product rule or quotient rule to simplify things a little bit first, and then cancel those bases. We'll look at some more complicated exponential equations in the future, but that's it for this lesson. Have a wonderful day.